Today we're going to look at a problem from section 4.3. We're going to approximate the area under a curve using rectangles. And in this case, we're going to use three types of rectangles: inscribed, circumscribed, and then we're actually going to use midpoint. So the function is 4 minus x squared. We're going from 0 to 2, and our delta x, which is the width of each rectangle, is 1/2. So from 0 to 2, that gives us 4 rectangles. And we will start with circumscribed. And in this case, that means that we start here with the left endpoint. And notice we're going to draw 4 rectangles. Circumscribed means that we have that little bit of the rectangle outside of the curve. So this approximation will be greater than the actual area. And so we have the width is 1/2. The height for the first rectangle, we're using 0, f of 0 for the height. 1/2 for the next one, f of 1/2. The next left endpoint. And then the next left endpoint is at 1. So we have 1/2 f of 1. And the third left endpoint is at 3/2. And so the height is the function values at 0, 1/2, 1, and 3/2. And then each has a width of 1/2. So I'm going to factor out the 1/2. And I'll show you a little bit on the calculator how to do some of this a little bit quicker. So in y equals, we'll substitute or enter rather our function 4 minus x squared. Go back to the home screen. Let's see if I turn on a light here. Maybe that will help a little bit. There we go. And now what I'm going to do is go variables, y variables, enter for function, and enter for y1. And notice when I substitute 0, that gives me the function value of 4. And if I hit second, and let me see if I'll push this up a little bit, enter, that brings up the previous command. And what we want to do now is I'm just going to scroll over and enter 0.5 to get that function value. I'll hit second, enter again. I'll hit 1 and delete the 5. Gives me a function value of 3. Second, enter. And now I'll substitute 1.5 to get 1.75. And if I take 4 plus 3.75 plus 3, 1.75, multiply by 1/2 or divide by 2, that area is 6.25 square units. All right, now we're going to use the same region. And instead of doing circumscribed, we're going to do inscribed. And so for a decreasing function here, that will be the right endpoint. And that's the last one is there at 2. So my area is 1/2 f of 1/2 plus f of 1 plus f of 3/2 plus f of 2. And we've already computed 1/2, 1, and 3/2. So I'm going to just use those values here. F of 2 we can see is 0. And so now when I add those up, divide by 2, we get 4.25 square units. And we can see that we have this area here that it's not been included, just like we had some area here that should not have been included. So our actual area is going to be somewhere between these two. Our third approximation that we're going to look at is the midpoint. And so what that means is that the midpoint in each of those four regions is what we're going to use to get the height of each rectangle. And you can see visually in each one we have a little bit of an area that we did not include, and then a little bit of area here that should not have been included. And so this will give us a better approximation. And our midpoints here between 0 and 1/2 is 1/4. We then have 3/4, 5/4, and 7/4. So each width is still 1/2. So now our function values we're going to compute are at 1/4, 3/4, 5/4, and 7/4, and each of those you would plug back into the 4 minus x squared to get the function value there. And in computing all that, our area is 5.375 square units. And you will learn this later on if you've not already learned it, depending on where you are in your course. The actual area here is 5 1/3. So you can see the midpoint was pretty close to that. And then obviously in between the circumscribed and the inscribed.